All right. So we're going to talk about containers, Docker, and my binder, and putting all these things together to publish reproducible workflows. So first, what are containers? So a container is a package that bundles everything you need to run some software. So it has all the system dependencies. It has the software dependencies itself, um, the software needed to run it, and all the actual scripts or code to run your software. So it's in a package that is portable and immutable, or it. I shouldn't say immutable, but you can ship it and run it on a different machine, and it will run the same way. It is OS independent, so it rides on top of your operating system and contains all of its dependencies in a package. Um, so this is a nice way to share something that needs to be reproducible. It is relatively easy to transport between machines, um, and can run on a number of different services. Docker is the one we're going to talk about, but Podman is a common other example. So why might we want to use containers for science? Um, I don't run into a ton of problems in R for reproducibility because R manages package dependencies a little differently. It's also writing at a bit of a higher level than Python is. Python has the advantage that you're able to do a little more powerfully. And R has the advantage that it's a little easier to manage dependencies. That might be overly simplistic, but those have been my experiences. Um, but containers add an extra layer of ensuring reproducibility by packaging all of your dependencies um, in one space. So similar to maybe creating a virtual environment that you're used to for Python, but a step beyond that because you have your system level dependencies packaged as well. So what is Docker? Docker is the engine that allows you to run containers. Um, so we'll introduce some concepts here. So starting from a build script, commonly a Docker file, or a Docker compose file in YAML, or a GitHub action. So we start with a script. From our script, we can build an image, and the image contains all the information necessary to reproduce that environment. When you have something up and running, when you have that image up and running, we call it a container. And that container runs on some sort of container engine, like Docker or Podman. And then finally, there are repositories for these images, and those are Docker Hub or Quay most commonly. There are a number of others. You can even create your own. So the basic workflow for this is writing that script, um, building and testing it out locally, um, and then pushing to a repository somewhere to share. All of this can be automated in GitHub Actions. You can also do it locally from GitHub Desktop, or I'm sorry, from Docker Desktop or from your command line. So here's an example of what a script to put together an image looks like. This is a Docker file. Docker file always starts with the command from. So this is the image you're starting from. This could be a very simple image, like a base Linux image, It could be something more complex, like uh, SciPy is a common one for Python that packages the scientific packages for Python. Um, and you can build on top of that iteratively. Another common command is copy, and this is bringing files from your local system into a container. Um, there are several other commands that you put into a script like this. As I mentioned, you can also build containers automated with GitHub Actions. So this is this is a way to make your container build process more reproducible as well, because you're able to run that in the cloud and share your workflow file in the same place that you have shared your code that you're trying to share with the community. So you can build, you can test some use of that container, and you can share the container where it's deposited in Docker Hub, all from your GitHub repository. So a next step in making your code accessible, so the container really goes a long way to making your code reproducible. But I think of my binder as the accessibility part of FAIR, because you can run your container in the cloud. You can launch it from a little link in your README file in GitHub and have instant access to your code base within the environment that you used. So what is my binder? So my binder is a place on the cloud to share your code in its intended environment. So under the hood here, there's some software called Repo to Docker. So this is automating the process of building a container. So you do not need to go through writing a script. The Repo to Docker code base will take your repository, assuming that it has the correct files in the correct places, and create a Docker container and launch that container in the cloud in my binder. So my binder will allow you to access that computing environment and all of your scripts or your notebooks in the cloud in Jupyter or in RStudio. I think there are a couple of other options as well, but Jupyter and RStudio are the ones that I'm most familiar with. So just reiterating here how this is all coming together. So you've created a repository in GitHub which has all of your dependencies in an environment file. Repo to Docker is doing the hard work here for you. You don't need to write a script to create a container. Repo to Docker will sort this out for you. And Repo to Docker will create a container for you, and you can launch it in the cloud in my binder. This is a really kind of straightforward way to make your science reproducible, assuming that you can fit into a Repo to Docker workflow. After you've set this up, you can create a launch link in your README file, as I mentioned before. So it looks like this little badge here, launch binder. And there are a number of templates offered. So this binder examples repository on GitHub offers a lot of examples. When I go through the R demo, you'll see that some of these R examples are currently broken. So there are workarounds. So I think something to keep in mind here is that this Repo to Docker software under the hood is maintained as a free service that is fairly complex. There's a lot of moving pieces to it. Also worth noting that this is Python based. So the original setup and intention is to work with Python, and R rides on top. So the Python aspects of this, in my experience, are more stable than the R pieces. But there are ways to make both R and Python work separately and together. There's also support for I'm forgetting the name for the MATLAB open source equivalent, Octave. Octave. So there's support for Octave and Julia here as well. I have not tried those out myself. So understanding the how these things relate, Docker and MyBinder. So there are use cases for both, and they can also work together. So creating a container and running it in Docker means you're running it locally. So you can create these things, you can create these Docker images with a local script like a Docker file or using Docker Compose. You can run these things locally. So you can run an instance of RStudio Server or Jupyter Hub locally and launch all of these things locally, or you can launch them in the cloud. And the convenient part for that is the accessibility piece. So putting a link to MyBinder in your GitHub repository allows instant accessibility to your coding environment. So it's much easier to share. If you're trying to share something that takes a fair amount of compute, however, MyBinder can be a little bit slow and cumbersome. There's also an aspect to this of the actual building of the container in MyBinder. This can take some time if you're doing it infrequently. If the resource is not being used on a regular basis, MyBinder will have to rebuild your container from scratch when that link is followed. So that's another consideration. Some people will give up on using your code because it takes 10 minutes to spin up in MyBinder. So I mentioned some trade-offs for computing and how to use the resources. There's also a bit of a learning curve to using Docker and the scripts that you have to write to build an image. When you're getting all of these things running on your local machine, you're doing it interactively, and you get immediate feedback when something doesn't work because you're missing a dependency, say. But when you have to write it all in a script, it all has to flow step by step, and one hangup will hang your script, and you'll have to relaunch it after you've fixed the issue. There's a bit of a learning curve to writing a Docker file script, and I think once you have the hang of it, it's a really powerful tool for sharing your code and making it more reproducible. MyBinder, a little bit less so. A lot of the automated processes, assuming that you are doing something straightforward like sharing pure Python or pure R in an R script, an RMD file, or a Python script, or a Jupyter notebook, all of these things, assuming that you're doing it straightforwardly in pure Python or pure R, are somewhat more straightforward. Yeah, so just a quick recap. You're we're thinking about containerization here. So you are packaging everything that's necessary to run your code in a shippable container. So this container can be shared. It can be stored on the web where other people can access it. And it contains everything from system requirements up through your Python or R libraries and your specific version of Python or R or both, and any code that you might be sharing as well. MyBinder is a place to share this online in a RStudio environment or a Jupyter Hub. And this makes your code more reproducible, and is also a boon for accessibility. And yeah, happy to field questions.
I guess is there kind of a like a general cap? I guess what kind of improves like, how fast like a binder container speeds up and stuff like I guess think what's kind of
Yeah.
the scope and scale of it, like a typical project that should go into this?
Um, yeah, so I suspect Deborah has more insight on what um, the allotment that MyBinder gives out per instance. I'll say real quick though that the spin up time for getting an instance of MyBinder to launch is greatly improved by caching a Docker image. So I mentioned before that you can share um, your container images on Docker Hub or Quay. Um, if you cache your image on Docker Hub or Quay and link to that with MyBinder, your launch is much, much quicker because it's not building from scratch each time. As far as the compute resources on MyBinder, Deborah, do you have an idea for what you get per instance there?
Not anymore. When it was Google, I did, but now that it's being bought by, well, not bought, financed by other people, I'm not really
Yeah.
sure. I mean, I wouldn't, you're not going to be able to get gigabytes of data in there, and you're not going to be able to do like long computation. I think it does time out after a while. It's really meant for like exploratory type of things or like lightweight type of things.
Yeah. Well, that's the end of that section of slides. If you want to stop the recording and we can move on to the